So we're going to look at continuous compounding, but as a reminder, the compound interest formula, which is, not continuous, sure I can write here. Right, is A equals principal times 1 plus R over N to the NT, right? Remember, P is the original amount you deposit. R is the stated interest rate. What was N, you guys? Anybody remember what N is? Nobody remembers what N is. It's the number of compounding periods per year, right? So if your investment gets compounded monthly, right, that's 12 times a year, so N is 12. If it gets compounded quarterly, N is 4, right? We're going to talk about the compounding periods here in a minute and what the actual effective rate would be. But as you recall, down here in the box is the continuous compounding, right? So continuous compounding, you remember, is really like an infinite number of compounding periods per year. Like, monthly is 12. If it was daily, there'd be 365, compounded every second, every nanosecond, right? And so on and so on. So it would be A equals PE to the RT, right? Remember, this is an infinite compounding. Right? And R is what they call the nominal rate, which is just another word to say the stated interest rate. Right? If they tell you it's 5%, that's what they state. But if there's multiple compounding periods, the actual rate could be higher than the stated rate. We'll get into that in just a minute here. Let's take a look at an example here. So example 1, you get a person who invests $350 in a bank account, right? So that's your principal, at a nominal rate of 2%, right? 2%. So what number do we use in our formula for 2%?
2.02.
0.02, right? You got to divide it by 100 to use it mathematically, okay? Continuous compounding, so that's our PE to the RT, per, whatever you want to call it, right? So let's write an equation for the amount invested in part A here. What would it be worth after T years, right? Well, that's pretty simple. The amount as a function of time would be what?
350.
350, that's our P. E to the...
And it went 2.02 T.
T,
Time
in years, right? Okay. So it's pretty straightforward. In part B, how much will the investment be worth after 20 years? So all we do is take that equation we just wrote and put a 20 in for the T, right? So A of 20 years, right? The amount after 20 years will be 350 times E, the 0.02 times 20, right? And that's just a simple matter of throwing that in your calculator, right? Let me pull that up. Make sure we all know where the E to the X button is. Maybe some of you using that decimals thing and might be in a different location, but so 350E, right? So let's do 350, and here is my E to the X button, right? Was it 2%? 0.02 times 20 all up in the exponent there, right? And we have $522 and 2 decimals for money, right? And 14 cents. Okay? 522.14 after 20 years. Not much, right? But that's a very low interest rate. Let me go back to here. So A of 20 equals, what did we say was 522.14. And do make sure you know how to round correctly. Okay? 2 decimals for money. All right, so part C. So here's the part where we're going to bring into play what we learned about logarithms, right? So we're using the natural logarithmic number E, right? So the log that will undo that will be the log base E, if you remember, right? And the log base E, what was the name for that? Remember the name for the log that was base E?
The
Okay.
natural,
Yeah, natural log. That's the ln one, right? And it undoes, e to some power. Okay. So let's take our equation then. 350e, we want to know when it'll become $400. So $350 times e to the 0.02 t, right, is going to at some point equal $400. And we want to know when, so we got to solve this for t, right? So hopefully we're going to end up taking the natural log of both sides. But what do we have to do first?
we're gonna divide each side by 350.
That's right. We got to clean this thing up, right? So if we divide by 350 here and over here, on the left side, we end up with e to the 0.02t equals, we put that in the calculator, we're about a few decimals, 1.1429, I believe, when we divide those over there. I want to go out a few decimals because when I round back to 2 decimals, it'll be more accurate. Okay, so I want to get that variable t out of the exponent. And it's a natural exponential, so I'm going to take the natural log of both sides, right? So the natural log of e to the 0.02t. So this is a little bit different than what we did yesterday, right? We don't really need to bring the exponent out front because the natural log undoes the natural exponential. So the natural log of 0.1429. Okay? So if this natural log undoes this natural exponential, all we're left with is 0.02t, right? Because they're inverse functions of each other. Equals natural log of them. I'll just leave it like that. And now we have one more thing to do, and what is that? Divide both sides by 0.02, right, guys?
Yeah.
With me? Okay. And they want us to round to the nearest tenth of a year, right? So we'll put that in our calculator, I guess. There is a natural log button. So this calculator here, it only has this log base 10, and you can see it has natural log here, doesn't it, right? It doesn't have, you can't do log base 3 in here, log will change the base or anything, right? So we're going to take the natural log of, what was it, 1.1429? 1.1429. I'm going to get outside the parentheses, we divide by 0.02. Are you with me? Okay. So to the nearest tenth, how many years will it take to reach 400?
It'll take 6.7 years.
6.7 years. Okay. So t equals 6.7. All right, so do you see this when we apply this logarithm here? This is a little bit different than what we did yesterday. We could have taken the common log of both sides, log base 10, and moved the exponent out to the front and divided both sides by log, and we've gotten the same answer. But it's good to see, varied techniques from time to time. Now, over here on part D, let's read this. I'm going to have a note for you. It says, what is the effective annual rate? Let me ask you a question. Let's say that we had this investment for 1 year, right? And it was only compounded once per, so basically no compounding, right? And then let's say we have the same investment for 1 year, the same rate, but now compounded 12 times per year. Which one do you think will have more money at the end of it?
The 12.
The 12, right? And maybe if it's compounded every day, 365 times per year, you think it'd have even more money, right?
Yeah.
The more compounding periods, the faster it'll grow, you might suspect, okay? And so what happens is then, whatever their stated rate is, if there's more than one compounding period, there's something called an effective rate, right? An effective annual rate, which is going to be a little bit higher, I think, right, than the stated rate if you compound more times per year. Okay, so this effective annual rate is also known as annual percentage yield. Right? Or APY. Some of you may have seen that acronym, APY. Let's want to investigate something here real quick. Make sure we're clear on this. Because this is really kind of an important thing. Like all the things you learn, man, well, I'm not going to use this. But, you know, when it comes to how money works, I think that's a pretty handy thing to have some familiarity with, right? So let's investigate just a little bit here. Just go to the notes page. Now, as I said, the annual percentage rate, or the APR, okay? So that is what the stated annual rate of interest, the nominal, right? So this is the stated annual interest rate. Okay, and in our previous example, that stated rate was 2%. But then, if we have more than one compounding period, we have an APY, right? Now, the APY is the effective annual rate given compounding. Effective annual rate given compounding. Okay, and we just talked about it, right? You guys suspected that the more times per year you compound, the more your money grows, right? Which is an actual, effectively, a higher rate than what's stated, okay? And actually, this becomes super important when you guys go to borrow money because it works the other way, right? So like if you borrow money at 5% interest compounded monthly, you're actually paying a little bit more effectively than 5%, right? So the APY can hurt you if you're borrowing. It can help you if you're saving, if that makes any sense. Well, let's just start with a real simple example. Yeah, I don't know why it does that, but anyway. So for example, let's say we're going to just invest $100. Nice, easy number to work with, right? And we're going to invest it for 1 year. Okay, another nice, easy number to work with. That way our T can just be 1 when we work through things. And we're going to say that we have a 10% APR stated, okay? So let's look at if there's no compounding, right, or just compounding once per year. So let's take a look at this for N in our formula equaling 1, okay? So we would have $100 times, this is the simple version, right, 1.10 to the 1, right? Right, because there's only 1 year. And I bet you can do that without your calculator, 10% per year. How much money will you have at the end of that year? What's 10% of $100?
90, right? $10? Oh, 10.
10. So we're getting an extra $10, right? So we end up with $110, right? The 100 we had in there plus the other $10 the account earned. You with me? So now let's say that we make the same investment, but now compounded quarterly, still at 10%, still $100, right? So N would equal 4, wouldn't it? So it would be 100 times 1 plus, right, divided by 4, 10% divided by 4, to the 4T, right? But T is 1, so 4 times 1 is just 4, right? All right, so let's go to our calculator real quick and see what that ends up equaling. You guys can plug this in your own if you like. I'm going to do 100 times 1 plus 0.1, I just put 0.1, whatever, 0.10, divided by 4, right? Arrow over to get to the 4th power, so x to the y 4th. Now, do you think this is going to be, the last time when it was compounded once, we ended up with $110. Do you think this will be more or the same or less?
It would be more.
Let's see. Okay, a little bit more, 110.38, right? So we end up with 110.38, a little bit more after a year, okay? Well, let's try compounded monthly, right? We're still at 10%, right? But notice we made some more money than compounding once. So let's do 100 times 1 plus 0.10 divided by, oh wait, whoopsie daisy, 12, I said monthly, right? I'm not that smart. To the 12th power, okay? So it's still at 10%, but now it's compounded monthly. And remember, originally it was just a, did I write that wrong? I'm having a hard time today. Look at the first one I wrote. You guys see the mistake I made? Don't you guys all stop me when you see that? All right, let's go back in and find out what it ends up being compounded monthly. So I can do that. Look, some calculators will do this. I can go over, just like hit that and bring it back down. All I got to do is just change this to 12, right? Change that to 12. Easier, I think. So now we're at a little bit more, 110.47. Okay? So now we are at 110. What did I say it was? 47.
It's up by 11%.
Yeah, right. But it's still 10%, right? So are you suspecting that even though the stated rate is 10%, as we compound more often, the effective rate is a little bit higher? Let's try one more. God bless America. Let's try daily compounding. 365, right? So it'll be 100 times 1 plus 0.10 divided by 365 to the 365 power. Let's see what that ends up being. Still 10%, right? But the only thing that changed was compounding more often. I'll bring that up. So bring that down. We'll change these guys to 365. 365, right? Same formula. A little bit more, 110.52, right? So we end up with $110.52. Okay? So all of these, right? N equals 4. Wasn't that greater than 10%? Effectively?
Yeah.
Weren't these all greater than 10%? Even though that was the stated rate, the compounding makes a little bit more. So in this last one, compounded daily, how much money? We put in $100 originally, right? How much money did we actually earn on this account after 1 year?
52.
Well, we earned
52 cents.
we earned $10
Oh,
and 52 cents. Not how much more than the rate, just how much, right? Earned. Okay, so let's figure out what the effective rate was, the APY. So let's take this and how would we do that? Well, we'll take this amount that we earned, 10,
no, which is 100
divided by what was the original investment?
divided by 100
100, right?
equals
Equals what? .105. What is that
point
as a percent?
That is how much the percentage on.
So wasn't that effectively 10.5%? You guys follow me? So effectively, we're getting a 10.5% return on our money, even though the stated rate was only 10%. And then maybe you're going to guess that if we do continuous compounding, it might even be a little higher than that, right? Infinite number of compounding periods, right? So if you're saving money in the bank, you're saving your money in compounds more often than another bank with the same rate, you want to go with that bank, right? If you make a little bit more money. I didn't see much like on $100, but I can tell you like another 0.5%, you know, when you get older, maybe you have $100,000 to invest, then it starts to get pretty darn significant, right? Okay. All right, let's go back and play around with this. Does anybody have any questions on what I just talked about there? Anybody confused about any of that? I'll go back if you are. Okay. Well, they want us to find the effective annual rate, okay, for this investment. Now, the stated rate was 2%, right? But we're compounding continuously, and I think we know it's going to actually, the effective rate will be higher than 2%, won't it? Okay. So so this was compounded continuously, right? What would it be if compounded once per year?
It'd be n equals 1.
Yeah. If compounded once, right, we would have, our formula would be, we would be using 1 plus r, right, to the t. That make sense? So divided by 1, right? It just doesn't change anything, right? So if we want to find out the effective annual rate, we need to see when this is equal to the continuous compounding factor, right? So we need to see when this, let me replace the word once with annually, right? If compounded annually. Okay, so we need to see when this annual formula right? Well, let's put a 1 in there. It's going to equal our E, right? Yeah, I'm trying to think. This might be more clear. Let's see. Let's do this. We need to see when the annual equals continuous, and then I'll write them underneath. That's why we do math with pencil, right? And so then the annual was our 1 plus R for 1 year, right? When does that equal? When does that equal E to the 0.02 times 1 for 1 year? So we're going to do a little bit differently than we did on the notes page, right? You see what I'm getting at? I don't have to worry about the principal, like any amount. I don't have to have the P in front of any of it. So all I have to do is figure out when this annual rate is equal to the continuous rate. When that equals that, what value of R? Well, let's start solving it. Let's solve it for R. So 1 plus R to the 1, that's just 1 plus R, right? So we can ditch the parentheses, can't we? Again, if I lost anybody, stop me and ask a question, please, okay? So 1 plus R to the 1, right, is just going to equal E to the 0.02, all right? So to solve this for R is pretty simple, isn't it? What do we do? What's E to the 0.02, somebody?
1.02.
Let's go out a couple decimals. If you put that in your calculator, 1.0202, I think, right?
Yeah.
And now what do we do to solve for R?
We minus by 1.
We subtract 1. So
Subtract
R,
by 1 on both sides.
yeah. And this is easy to subtract 1 from. It's just going to be 0.0202, right? And what is that as a percent?
It would be, wait,
Just move the decimal twice to the right now. Going the other way.
yeah, it'd be 2.02%.
So a little higher than the stated 2%, isn't it, after 1 year? So our APY, the effective annual rate, is a little higher than the stated rate because of the compounding, right? Equals 2.02%. Okay, even though the stated rate was 2%. Okay? So this is handy stuff to kind of get into your brains as you go out into the world at some point, right? You save money or borrow money. Because if you're borrowing again, it works the opposite way, right? You're the one paying the interest rate to the bank. They're the ones making the money off of your compounding, right? Okay? Does anybody have any questions on anything we did here today? This is the only section we're going to do.
Oh, we're not doing number 6, lesson 6.
Either there's not one or we're not. No, we're going to skip 6. We're skipping 6.
Oh, okay.
Yep, sorry.
Are we gonna able to finish all the units?
Hang on one second. Let me stop.
Because I
this here.
got to 13.